Hey, welcome to our first in-class lesson today. So, previous to this lesson, we've set up some rules for drawing, and today we're ready to put some of those rules to use. So, by drawing an object, and what we're going to draw today is a round pipe with a 22.5-degree bevel on top. Almost as if I put this pipe in a saw and just cut this 22.5-degree bevel. I'm just going to produce this with a pattern. And so, we're going to be working with 3.5-inch Schedule 40 pipe with a pipe length of 7.5 inches to the longest point and a pipe bevel at 22.5 degrees. So to do this, we're going to use two views, kind of a front view or an elevation view. And we're going to draw this in a 2D format. And so we would start with an elevation view that shows one direction of the pipe. Then we need a right side view. And so we need these two views to kind of communicate to each other to define what the bevel looks like, and to define how this round part would stretch out in a flat pattern. So then we'd also have to draw this right side view, and then project some lines. And I'm just going through the rules here. Project some lines that would talk to each other, and this would kind of you'll see the bevel in this drawing. And let me just show you like a 3D model of what this drawing looks like. So when we're done, we're not going to produce this 3D necessarily, we're going to produce a flat pattern, but it does represent this drawing here. So that's just a piece of pipe with a bevel in it. And what we would produce here is something I could actually wrap around that to define that cut if I didn't have a saw that I could fit this in. So it's a paper pattern that would go over the outside of this. My pattern could actually make the part if I defined the metal thickness and adjusted for that if I was to roll it around. But we're just going to be working with paper for this project, and so we don't have to do a lot of stretch out figures for this. But we do need to know what the diameter of this pipe is. The outside diameter of this pipe. So it's 3.5-inch Schedule 40 pipe. So to find and we know it's 7.5 inches long to the longest point here. So we need to find this OD to be able to draw this. And we'd have to reference a chart for that. So I have a chart here that shows some standard pipes diameters. We're working with 3.5-inch Schedule 40, and this gives me that it's 4 inches in the outside diameter. So that's the information I need. It also gives me my wall thickness, and it gives me the wall thickness for Schedule 82, which doesn't come into account unless I'm actually going to make this out of a metal thickness. So what I need currently is just that it's 4 inches OD. So with that, I'm going to take this to my drawing AutoCAD program, and let's start with drawing this elevation view of what this looks like to develop that. So this pipe is 7.5 inches long. I'm actually drawing in green. You'll see that I kind of use a color-coded system just to it helps keep me straight and keep everything so I know which lines are which lines. You can come up with any color system you want, but so it's 7.5 inches tall. So I'm going to make this line 7.5. It is 4 inches OD, so this becomes 4, and this is 7.5. And then I can close this off C, but this is going to be 4 inches, or snap to it there. So now I've just got a rectangle that represents my pipe. It doesn't show the miter here. So in this elevation or this front view, I should see this miter depicted here. That I'm given that information. It's 22.5 degrees. So I need to draw that in across this, and then kind of trim out the top of this rectangle that doesn't represent my pipe here. So to do that, I'm just going to grab me another polyline. You just have to make sure on your polar tracking here that I'm tracking to those degrees. These are degrees here that I can choose. And so if it's default setting here, I can only really snap to 90s or 180s. I can change that to 45s or 30s or 23.5. Well, actually, that's what I want. I want a 22.5 degree, but AutoCAD's going to round that up to 23 degrees. So if I choose that, it should give me that as an option. I can refine this all the way down to 5 degrees, 10 degrees, which almost gives me every angle that I have the option of here. So let's just select. I know I'm looking for a 22.5 degrees, so I'm going to select that, and this is going to be beveled down to my right here in this view. So I'm just looking at the degrees that it's given me there from where I've snapped, and you can see that this is going to snap to a 23 degree. So that's kind of nice. Right here it says it's a 22, so I can actually like bring this out just a little bit long. That's a 23 degree. Can escape from that. I can just kind of tuck this into the side. I've got my intersection points so I can snap to it. And that's that here. I can change what I can snap to through this menu here. My object snap settings. So I will toggle these on and off depending on if I can't get it to snap to what I'm looking to get it to snap to. So that came up just fine. I'll escape from that menu. And when in doubt, I can check this. I can check this angle. So over here, where my annotation, where I can like make a list or dimension this out, like we've been done, I can just check an angle dimension here by selecting that, selecting these two lines, and then choosing where I'm referencing. So I do see that that is a 23 degree, which represents my angle of cut here. So that just shows me that I'm on target. I'm not going to leave that on there. It's just a quick reference. And what I want to do is trim this. So we use our trim command. So I'm actually trimming these objects. So I select them both, and then I'm going to trim out those two. And that now represents a pipe in an elevation view, front view, with a 22.5 degree miter on top. So that's kind of our step one. We still need to work with this view, and now what we need from our previous lessons, we've learned how we divide our circles, because this thing is a circle, even though, and so I can use a circle drawn in on the bottom to kind of represent it, almost like if I was looking at it from a top view or a bottom view, a plan view that way. But to do that, I just kind of do this like hybrid system of putting a kind of a semicircle on the bottom of this. And that's going to help me develop equal space points around this that I can project. And so to do that, I'll go back to my green here, and I'm going to do a circle, and I'm going to snap. I have midpoint as an option to snap to, so snap to midpoint and draw me a circle. And we would divide, our circles we divide by 12. So I could divide this by 12, but I'm going to work, you'll see me work with semicircles a lot, and I just divide them by 6, because in this view, two of these points line up with each other. And we talked about that in previous lessons. So let me trim this out to my semicircle. Like that. All right. And that just kind of represents these are just for development lines is what these are. It's not part of the object. And so to differentiate the stuff that is just lines that I'm using for development, I usually make those just dashed lines instead of solid lines. So I come up here to my properties tab, and I can choose. I only have these options of lines right now, but I can load other lines. I bring up this tab and select this load tab, and I just prefer to have like a nice tight dash line for my development lines. So I'm going to choose -2 and say OK, and now I have that as a line type that I can draw with. So I'm actually going to change this to a dashed line. Yeah. And now I need to divide this by 6, because it's my semicircle. So choose Divide tab over here. Divide, select my object, and I right click, or it's asking me the number of segments. I'm going to do 6, and that will establish some node points. To have a dashed line is kind of nice because I can see that I have a node point that showed up. And so now I have from this point to this point along this, I have 6 equally spaced node points to snap to. And that's what I'm going to use next here. So I can do a quick check of my dimensions here. I'm just going to switch to white for my dimensioning tab, and I'm going to dimension, I guess, some linear dimensions here. Make sure that I'm 7.5 inches here. That looks good. I'm going to repeat that. Just make sure I got the right outside diameter before I get too far in this drawing. Okay, so that looks good. I'm 7.5 inches along this point. I checked my miter bevel already, and I'm 4 inches OD. So now, from these node points that I established, I want to project these up to where they meet the bevel. And that's the first step in making some lines that will communicate to my right side view. And they'll work together to kind of establish what this looks like, what this bevel looks like over here in a right side view. It actually looks like an ellipse is what we call this, that we're going to develop here. So to do my development lines, they're not actual parts of the pipe, they're just for my drawing purposes. I use dashed lines. And I'm going to use a line instead of a polyline. They're just straight lines. I've just found that these are easier to lengthen or shorten and keep them parallel than a polyline can kind of be pulled off. So it's my preference to use a line for these. And what I do is I snap to these node points. So I have, there's 1, 2, 3, 4, 5. Yeah, and then these ends become node points too, but they're already hitting the bevel. So I like where those are, the outside of my pipe. I just need to draw in a few other reference points. And so when I do this, I start at the node point. I actually click here too because I want the length of the line that's actually on my pipe. And from my semicircle up to the bottom of my pipe is not part of the line that I'm going to copy and paste to make my flat pattern development. So I actually just end it here perpendicular to that, and then click again where it crosses the bevel. And so now all that does is give me a true length line that's across my actual pipe part. And anything below that in the semicircle is just used for referencing only. So I'm actually going to copy and paste these lines, is why I want these to be a kind of a true length. So I'm going to repeat this on every node point from here to where it's perpendicular to that, and then where it intersects this. Yeah. And then here's one other trick that I have is I like to differentiate my center line on my pipes. On round objects in general, we work from center lines a lot. So I tend to differentiate that color, and I'll just choose yellow. It's my default color that I like to use. And I'm going to do the same thing here. That becomes more of a factor as I do other developments to get a little more complex. I'm always referencing center lines with round. So now I can go back to my white color and draw in the last few development lines here. So and it ends there. Okay, so now I have these node points, and all I've done is kind of define some lines that give me information on where they hit this bevel. And so that just becomes crucial information to lay this out. And these could be really any spacing. It's just that I need them to be equally spaced around the round object. And that's why in this view, they don't look like they're equally spaced across the elevation view. But they do when I'm actually thinking of how they are in relation to the object being round. And that's what I get by doing this sort of development here. equally spaced, 6 equally spaced around this semicircle. So that's great. That's a good start to my elevation view. I just need to now look at this thing from the right side view and draw that in over here. So I'm going to use projection lines to do that too. I can just use polylines here or lines. And I need to define how tall it is over here. So I just use this object to do that. And you can just project this over at really any length for the moment here. And repeat that for the base. So kind of defined in the height here. And I can switch these to a solid line. And my green line. And then I just need a little bit of space in between my two views, just like we do when we draw. That actually has a midpoint of that line that I drew, so I'll snap to that, and that's fine. And then perpendicular here. And then this, so that defines the 7.5 inch tall view in the right side view. And this is going to be 4 inches OD. It's going to be the same looking at this way of the pipe as it is the other way. That doesn't change the diameter of the pipe. So 4 inches there. Back up to this line. And I can close this off. C for close. And now I've kind of just done the same thing. And I can tuck these. I don't tend to leave this stuff long. I'll just tuck it into where I needed it right there. And the same goes for here. I pulled those long just to define it, and now I can tuck them in. Kind of like we would on our drawing pads when we're doing this by hand. So that is the right side view, but we don't know exactly, this doesn't define what the bevel looks like in this view, but we use this information that we've established and bring it over here to actually define an ellipse. So, which is what it would look like in this view. So we can develop, what we need to do is put the same projection lines, and then these two will talk to each other, make a grid up top. So what I mean by that is, let's take and do another development circle below here. And trim that out, because I only need half that circle. Alright. And then while I'm here, I'll divide the circle into the 6 segments. Great. And now let's draw some projection lines. So I'm going to go back to my white and project these up. I'm going to project these up just to the overall height here. So, because I don't know where they would, where they would end here to define this. So right now I'm just going to pull them long up to the overall of this, and then I'm going to bring these across, and where they intersect, you know, their like counterpart in that view, is where I will then tuck them down to. So let me show you what I'm going to do. I'm going to take the same function. I'm going to take a line. I got these node points. Snap them off here. Bring them up long. And repeat this to the next node point. Perpendicular and all the way up top. Great. And this one I like to change to yellow to center line. If I did it white, you know, and you've probably done this before, I'll just stay with my white color. This happens all the time. I get in a groove and I forget to change to a different color. And let's say I did that here. Then all I do to change that color is select it and go to the tab, and just like that, just change to yellow. So the rest of them will be white. And repeat one more time. All right. So now, that's great. So now I kind of have these two views of this pipe, and I just need to define the bevel here. So in the elevation view, this is my center line, and in my front view, this is my center line, and so that's kind of the easiest point to start here. I can tell these two are going to they're going to be the same, kind of the same line here. So if I'm looking from the right side view at that elevation view, that center line kind of becomes the outside edges of my pipe. If I rotate that, 90 degrees is what we got. So we have to train our mind to kind of see that. This center line becomes the outside view here, and this center line now becomes the outsides of this, and they're in line with each other. So I'm going to do one last thing here. I'm going to explode these lines. I'm going to need these. I'm going to explode that and this. Just because when I go to make my pattern, I need these to be just an independent line. And when I drew them as a rectangle, they were joined. So now I've got them independent. So what I mean is, we're going to project this over, and I'll choose a polyline for this command. So I have to kind of think like this outside edge of this pipe becomes the center line over here. So if I was to project this over, I'm telling it that that's where the center line kind of ends in this view to depict this outside surface. And then this outside surface is the center line back over here. So now working out from there, I match up line for line. And so for me, it's easy to work. Since I've defined where that one is, this next one is going to be the next line next to it, or the next two lines. So what that looks like is this one's going to project over and be the next line out from here, which is going to be here and here. So I'm actually going to, because these two are lined up in the elevation view. So I'm going to snap it to this furthest line, and then escape that command. And so this point and this point in this view represent this line right here. And we repeat that out for the next line now. So this one now comes across, and I've already defined the point for that line and that line. So these ones now pick up this point and the furthest out point here. So I get this, what I'm building is this grid pattern. And so I've got one set of lines left, which are going to be the center lines here, because that line I know represents the outside diameter of this pipe. So that means it's a way to check yourself to make sure you're putting the right line in the right place, is that this one will now represent that and over here. Yeah, and that's half the pipe, because that's all we're seeing. That's actually all we're seeing, like from what I've defined here. I've only really defined half the pipe. And now the pipe comes back in to this center line. So I take the next line up, snap from here, and it becomes, now I'm kind of working the other way, like so now I'm working to this next line here, or this one here, and snap those, and then I'm going to repeat. And this one's going to be the next one in, coming back into the center line this way, or this one. That's great. That's it. And this one actually, I can now lengthen it back to where its true point, where it actually intersects, is right here. And so now this may look like a mess, but with a little bit of work here, and I like to, sometimes I'll put these in red just so I can see them, these ellipse or kind of my cut line here. So what you'll see me draw is maybe a polyline, and I'm going to define, so this is going to define what this bevel looks like in this view. We've just got all the information we need from that other view, and I can start it right here where I started, and I tend to use an arc. So with the P line I can change this to an arc by saying A for arc, and I use second points a lot. just to kind of make a round. And so I'm going to go S for second point, and that allows me to pick like this point and this point and kind of show them as round. And then I don't have to pick a second point here, but it kind of does what I want it to do, make it kind of round from there to there. I'm going to use S for second point again. And if I don't like the look of it, I can change it. So I'm arcing and second pointing along here. That one's going to end there. Come over to here and second point. I just go around this grid to define what that bevel looks like. And so at this point, I can actually tuck this in. This stuff out here becomes, it was just reference material to block this in, but it actually doesn't represent my pipe. This one actually ends right here, and this one ends across from it, and it should line up with my grid lines. This one kind of ends there. And I could use a trim command, but I do like just referencing again here where they tuck into each other here. So this one only needed to stop here. It's just tidying up my drawing. And this one actually ends right here. Oh, actually, I say I could get rid of that one if it doesn't represent my pipe there. So there's what it looks like. Using these projection lines, I've defined what the bevel looks like there, and I've created an ellipse, which now, in two views, I've defined that. So now, really, the information I need is actually for a flat pattern development exists in this view only. This is more of an exercise in drawing and representing my drawing correctly with two views and all the information from that. The only thing I would lack here is just to define, to say what this bevel is. If it was like a finished drawing, I've got the length and the width, and I would just need to define that bevel to have all the information I need. And so now we're ready to do the flat pattern development using this information here. So the way I do this is, I'm going to switch this to a solid line, is I can just use a line. What I like to use is a line that represents, I can just snap this, I'll usually snap this in line with what I'm going to actually make. So I'm going to match it up to the base here. And then this needs to, the length of this line needs to be the circumference of what I'm working with. So in this case, we were working with a 4-inch OD, or 3.5-inch Schedule 40 pipe, which is 4 inches OD. So if this is going to be a paper pattern, it really doesn't have a lot of thickness to it, then I can make this the circumference of the OD that it would wrap over. And that's what I'm doing here. And as we do other exercises, we'll actually change this to match the material that I'm working with. So for this, I just need to know how long the circumference is on a 4-inch OD round material. So I pull out my old calculator here, and this is 4-inch OD, which becomes 4 times pi to get my diameter, or to get my circumference. 4 times 3.1416. I'm just going to use that for pi. And this tells me the length of my line needs to be 12.5664. So that's exactly what I make that. It's 12.5664. And that gave me that line that now matches the circumference of that. So with that, I need, and that actually represents going all the way around this pipe. So that has all 12 points on our circle that we've just used to divide. In these views, I divided by 6 because they're just representing, in that view I'm only looking at half the circle. But this I need to make it 12 points. So go ahead and divide this by 12. And this established node points along here. Now sometimes if I remember to change my color to like a white, I can see those node points on here. If I make the node points the same color as the line, they kind of disappear. So you have to trust that they're there and that you can snap to them. So let's just see if they're there. And you can choose to develop this anywhere. You know, wherever I start like grabbing these lines and setting them on my circumference line kind of defines where I'm going to put my weld seam, or anyway, where I'm going to, it definitely defines a weld seam, or it defines where the seam of my paper pattern is going to be. So with that in mind, if I'm thinking of metal that I'm going to be working with, a lot of times I'll make my weld seam my shortest point. So where my pattern comes together when I wrap it around something might be from my shortest point, but I have control over that. You know, I could choose to start my pattern here, or I could choose to start my pattern here. What it would do is it would put seams that would line up. So for this particular pattern, and we'll talk more about that as we draw, but I'm going to start copying lines from this over to my circumference line. And to do that, let's use our copy function. And I said I'm going to start with the shortest line, makes the shortest weld seam in the case that this was metal. So select that object, I'm going to select it from this base point. And I've got that true length defined there. And that's going to become the end of my pattern. This is where my pattern comes together. So I actually have it there, and I'm going to drop it over here too. And then I just work out from here. So I need this line, this line, this line, this line, this line, and then I need those lines again, because when I look at this view, this actually there's two lines in line with that are the same length. They would be, if I come over to this view, it kind of helps me see that, they would be, you know, this point here and this point here. They actually have that same length. So, okay, so that's my next one. Copy those. And these go on the node points that match up. There's the node point. It pops up like that. And I come in from this side and drop it. And then we're ready to grab the next set of lines out, so I'm just going to repeat my copy command. And drop these lines over here. So I kind of come in close to this line and then toggle across here and wait for that to show me my node point. That way I make sure I just grab the next node point next to it, which is really critical here, to put the right line on the right, in the right position, because it's defining this kind of sweep of that bevel. And so this is progressively getting bigger until it gets to kind of the center point, and it will come and it will drop back down. And I just have to remember which one I've grabbed here. So I'm actually ready to grab that center point, which again, that color will come in handy again, because it will kind of break up my pattern over there that I'm developing. Because this becomes like, over here it kind of becomes our center points from our drawings, becomes our kind of our quarter marks here. And I like to keep track of center lines on round stuff and quarter marks, so kind of the 90-degree points around something. So that actually helps me define that. And I'm going to repeat this copy to my next longest line from the same. I'm copying them all from the same base point. And work in. There's my node. Work in over here. And I've got just a couple more lines to copy. This one. And this one. Great. And the last copy is this one, which should be the last node point here. If this tells me that I've got something wrong, if I've got extra nodes here. But that shows that these two are the same length. That's where my pattern will come together when I roll this up and that shows a nice even sweep. This is the high part. This should be 7.5 inches to that point, which it is, because we actually copied that line to make that point. And the low point is this, which is where I'm going to put my seam. And so this one matches that one. And then we just worked on here, and we have 12 points. So now all I need to do is draw this in, and I'll use my red, and I'll use my polyline to kind of arc and second point this to make a sweep. So arc and second point, and pick the points of the top points of these lines, which just make sure you're getting to that point. So it also, this is how I would draw this to make a cut file. I wouldn't want it to be just straight line segments from point to point. A sweep like this would make a better weld seam. It wasn't quite so jagged, so second point this one. Now to the end here. So now I've just kind of drawn in the sweep of what that looks like. When you roll that up, it's actually going to look like a sharp bevel like this on the side, almost like as if I had saw cut it. But we've defined that using 12 points, and you get this pattern right here. So the last thing sometimes I do is, this isn't all joined together, and so a lot of times what I'll do is just join this and maybe make just a nice clean copy of it with my quarter marks one more time. So I can change these to red. I like these to be the outside of my pattern. I'll change those to red, and then this helps me see that everything lines up too. Is I'll do a polyline edit here, and we're going to join the outside perimeter of my pattern. And if that works, that tells me that I'm lined up. If it doesn't work, see, I've got like an issue where I didn't quite get lined up there. So that's kind of an indicator that I've got something to tuck in a little bit tighter here. So I'll check this line here. Yeah. All I'm going to do is I'm going to do a move. Let me do an explosion here. I'm going to explode this now that I joined some of that. It's got a lot more segments here that I'll reconnect later. I'm going to move this in so it matches up. This can be really easy to do. These points sometimes don't snap in the right spot unless I'm really paying attention. So I'm going to move that in. And then this one, I can just tuck this one in to define the edge of my pattern. I'm going to do the same thing over here. I want to move this in. If I just tuck that in, it wouldn't be nice and square. So if I had just taken this and like tucked it to my point. So I'm actually using the move command. And I'm picking this point and moving it out to match my circumference line, because that's my critical length of line there. That's going to move that over perpendicular to my circumference line, which makes this just a little bit off now, but I can stretch these. And now when I do a polyline edit, this should connect. So let's do a polyline edit, and this, since I exploded this to be able to tuck it in, I've got a few more. It says yes, I want to turn it into polyline. I'm going to join this with this and this. All these segments. It just broke up each one of my points that I selected when I did my arc and second point. And now this is all one polyline. Great. Good. It worked. So if that happens to you, it happens to me all the time, obviously it did here, just really check the corners and see. And this is why I like going through this exercise, to just make sure that my pattern is all joined, especially if I was making a cut file. That would have caused problems to not have those connected. So I'm going to go ahead and make another copy of this. along with its center points and these quarter marks. These are the critical, they carry critical information to me that I like to keep. So I don't need, the rest are all just projection lines that define the bevel, but this now becomes something to work with here. That way when I wrap this around my pipe, so now I can print this off, but when I wrap this around my pipe, it contains the quarter marks that I can just like use a punch and mark those to the pipe so that I can have, so I can clock my pipes if I need to for good alignment. So it contains the quarter marks, and it contains a center line here, and then my other center is going to be the ends where they come together. So my seam will be on a center line, and yeah, that'll be great. That'll be good information to have. So that kind of concludes the flat pattern development of a 3.5 inch Schedule 40 pipe that is 7.5 inches long to its longest point on a 22.5 degree bevel. So what we'll do is I'll have a printed copy of this, and we'll take a look at it and how this actually ends up making what we drew over here. So that's all I've got for today.